All right, so looking at this one, I see a product inside the ln. So I'm going to encourage you to use your log properties first. This is not the derivative. This is just using log properties. So this breaks up into these two. And then again, this can be broken up. This using properties, this 2 can come down in the front. And this 3 can come down in the front. And there we go. So now to take the derivative. 2, derivative of ln of x is 1 over x, plus 3, derivative of ln of sine would be 1 over sine of x times the derivative of sine, which is cosine. So I'll get 2 over x plus 3, and I could write it as cotangent of x if I wanted to, or I could leave it as cosine over sine. Again, this would be a great one to use the log properties. So I see there's division on the inside, so that's subtraction. And then again, I'm going to take the time to pull those exponent down in front. Okay, now the derivative will be 2 times. Derivative of ln of secant will be 1 over secant times the derivative of secant, which is secant tangent, and then minus 3 times 1 over x. So this simplifies to 2 tangent of x minus 3 over x. All right, so let's look at this. I see that it's going to be all to the 1/2 power. So it's the same thing as saying 1/2 ln of x squared plus 16. Much easier to take the derivative. Carry the 1/2. 1 over stuff times the derivative of stuff. So the 2's cancel. So I just get that. All right, let's see what I've got here. So inside the ln, I have this function. And inside the arcsine, I have this function. So there's no exponent here. This means arctangent, so this does not come down in the front. So there's no simplifying I can do. This e to the negative x is inside this function. So the power has to be on this outside function here, and it is not. So let's start by taking the derivative. All right, so to take the derivative, I'd get 1 over the arctangent of e to the negative x. Now the derivative of arctangent is 1 over 1 plus the argument squared. Now I'm going to take the derivative of this, so that will give me negative e to the negative x. Minus. Now take the derivative of arcsine, 1 over the square root of 1 minus the angle squared times the derivative of the angle, which is 1 over x. And there's no simplifying that can be done, so I'll just leave it. Oh boy, look at this fun here. So this is implicitly defined because y is on the inside. So let's go take the derivative. So I could break this up to be ln of x plus ln of y before I begin. I don't have to. It will make life easier, so let's do it. So log base 3 secant of x squared. Okay, so this derivative is 1 over x. This derivative would be 1 over y times y prime. And then this derivative here would be 1 over secant of x squared times ln of 3, and then the derivative of secant of x squared would be secant tangent both of x squared, and then the derivative of x squared, which would be 2x. Now finally, to solve for y prime, so there's only one y prime term, it's right there, so let's leave it over here, and let's subtract that to the other side. And minus 1 over x. And then finally, to solve for y prime, you would just multiply by y. And I just distributed the y to both terms. All right.